This week's multiple choice Monday is about nitration of benzene, and this is a slightly unusual reaction, and it's telling us that the nitration mixture is concentrated nitric, which is HNO3, and sulfuric, which is H2SO4. Now, one of the things we have to remember is the equation for this reaction and how it generates the electrophile. Electrophiles are electron pair acceptors. They need to accept electrons from the benzene ring. Benzene is not particularly good at electrophilic reactions, and so it needs a really good electrophile. And in fact, this here, NO2+, is the electrophile in the reaction. So that will definitely be present in the mixture because that is what we're trying to make. So in order to substitute NO2 onto a benzene ring, we need an NO2 with a positive charge. So let's see how that works. Well, HNO3 is where the NO2 is going to come from. That's going to be NO2+. Having a look at what we have left over, well, I've got an H and an O, and because HNO3 has no charge, that means that basically what I've got left over here when I take away NO2+ is OH-. So what's actually happening here is we have two strong acids, but H2SO4 is the strongest acid. And what really happens is we don't ever really generate OH-. That's never going to happen in such a concentrated mixture. What actually happens in the middle of this reaction is that H2SO4 will donate H+ because it's a strong acid. So it will leave behind HSO4-. It's lost an H+. Meanwhile, what we've got here is H2NO3+, and that's the nitric acid behaving like a base and accepting H+. That will then break down to form NO2+, our electrophile, and simply water, which I would expect. And so the other product here is HSO4-. So that explains where the HSO4- comes from. What about H3O+? Well, HSO4- is also acidic because we know that normally when sulfuric acid goes in water, it will release H+ and make two lots of H+ and an SO4-2-. So the H2O and the HSO4- will combine together to make H3O+ plus SO4-2-. The other way to look at it is simply that all acidic solutions contain H3O+ ions. Okay, so there isn't really any such thing as a separate H+ ion. H+ ions are always bonded to water molecules in acidic solutions. Okay, which means that this is the ion that's not present because NO3- would only be present if HNO3 dissociated, which it normally would in aqueous solution, but it's not going to do that in this case because it's in the presence of a stronger acid, and so it's instead behaving like a base. So, my free chemistry revision club by email is still going on, Cation Club. Just sign up, drop me a message or sign up via my website. But also I'm starting live revision masterclasses for really small groups of students starting on Wednesday 1st of February. Because it's small groups, you need to get in quickly if you want to sign up to those. Again, you can find out more on my website or you can click the link in my bio.